I am Abigail Thompson, and this is my final WashU MEMS 5001 optimization presentation on the optimization of an employee scheduling system. The nurse scheduling problem is defined as assigning a series of shift schedules to numerous nurses over a planning time frame given some limitations and preferences. The NSP faces the issue of finding an ideal way to assign nurses to shifts in compliance with a set of hard constraints, which must be followed to produce a valid schedule. Studies and analyses have been performed on this problem since the early 70s. This problem is significant in regard to current high turnover rates seen in nursing staff, as well as complex scheduling seen in other strictly constrained professional fields. This is not a new problem and has a variety of approaches taken to solve the nurse scheduling problem. A few of these previously studied and applied methods include mathematical model solutions, global optimality approaches with MATLAB, a hybrid heuristic ordering and variable neighborhood search combination, and mixed integer programming. The problem being addressed is the optimization of an employee scheduling system, in this case a 24-hour nursing unit, focusing more directly on the nurse rostering problem to find an optimal way to assign nurses to shifts with multiple sets of constraints, with the objective to minimize the daily wages. The following is the solution method to this optimization problem. Applying MATLAB in an appointment scheduling model, it will apply both hard and soft constraints. Hard constraints consisting of if the constraint fails, it will result in the entire schedule becoming invalid, whereas the soft constraints are desirable, but if they are not met, it won't invalidate the schedule. This program has the potential to go across all constrained scheduling fields. The following provide the design variables for the problem. Some of the hard constraints include that staffing cannot dip below the minimum requirement at any hour, employees, the nurses, can only work one shift per day, and when scheduled, an employee cannot work less than their specified minimum or maximum hours. The given data will be an employee data sheet with the available work hours, employee's name, and hourly wage. And the minimum number of staffing needed at any given hour will also be provided. Peak hours may need more employees. The current approach will apply mixed integer linear programming and an accumulation of previously applied codes. First, pulling employee data from an Excel sheet, then generating matrices in MATLAB based on the various constraints and objectives previously stated, then calling integer linear programming, and then outputting and displaying the results. The mixed integer linear program was applied for 3 different variations of the given data to fit different nursing unit sizes. All the nursing units for this model are 24-hour units. The first was a larger scale hospital unit with 50 nurses, and then the following were both mid-sized hospital units running on all the same regulations, but one had 5 nurses less than the other. The following shows the results from the code. All the runs produce their own variations of the graphs displayed. These specific graphs were outputs from run 3. The graphs exhibit a nursing schedule to fit the given data presented in each case, as well as if the employees required meet the scheduled number. The model also outputs the heuristic optimal solutions of the minimum amount each unit would have to pay out. One interesting thing to note is in the optimal solution, it is sometimes cheaper for a unit to employ more nurses than it is to stretch thin the amount they have. Furthering this work, this could be applied to telehealth or virtual care, seeing as it is becoming a bigger factor in the medical field today. Incorporating this model to other medical professionals in a clinic or unit for a fuller image, which would also be beneficial to see if other optimization changes can be made in a clinic to see how the schedule could further function, and applying this model to other highly constrained working fields.